All right, so 12-3 is on how to find the area of triangles. Now, you already know an area of triangles formula. In fact, let's write this down while we're here. The area of a triangle, you learned like in 5th grade, 6th grade, is just 1/2 times the base times the height. Now, this works if you have a perpendicular height. So if you know two sides that are perpendicular, if you've got a right angle in your triangle, it works well. What we're going to do is we're going to talk about an area formula that works on triangles that are not necessarily a right triangle. Okay, so what they do here, though, is they draw this lovely triangle. So here they've called our sides or our angles A, B, and C. Remember, the sides across them have to match up with the lowercase letters. So across from angle A is small a, across from angle B is small b, across from angle C is small c. So they did draw this perpendicular height right there. Okay, so if we were to do this area of this triangle, it's just 1/2 times that base times the height right there. Now, they want us to find out what the sine of C is. So notice right here, I know this is going to go a little bit lower right here, but there's a nice lovely triangle right there that involves angle C. So if we're trying to find the sine of angle C, remember the sine is our SOHCAHTOA. So the sine here is the opposite of angle C over the hypotenuse. So in this triangle, the opposite side is going to be this H over my hypotenuse, which across from the right angle in this triangle is going to be A. All right. And then what they're wanting to do is they're wanting to substitute something in for H because H was not part of this normal triangle, the original triangle. So they said, okay, go ahead and just solve for H. We're going to solve for H. It's divided by A. So we're going to multiply both sides by A times the sine of C. So those A's just divide off. So H is equal to A times the sine of angle C right there. And then they say, okay, let's put that in for our H right there. We're just going to straight substitute that in. So our new formula that we're going to use this year, this unit, is 1/2 times B. That was the base of this one, or our little b, but it could just be any side B, times A times the sine of C. Now, before we get into using this formula actually is kind of like our law of cosines. If you'll remember, we had like 3 ways to write the law of cosines, just depending on how you label your triangle. So this is going to be the same thing. What I want to point out, you don't really have to remember A, B, and C and whatnot. What you have to remember is whatever two sides you use, by the way, you have to use two sides and one angle for this. So whichever two sides you use, you've got to use the other letter of the angle. Okay, also, I always just think about this. If you look at this triangle right over here, notice B and A, where B and A are. Here's B, here's A. The angle is always going to be the angle that's in between them. That angle C right there, it was touching both A and B. So side, and the angle in between them is how I remember it. So we're going to label this first triangle, but then I'm not going to label them after that when we're finding area. So let's go ahead and do this. We're just going to call this A, B, and C. So this means that across from angle A is little a, across from angle B is little b, and across from angle C is little c. All right, now we're just going to plug in our values right here. So we have this area is equal to 1/2 times little b, which was the 15 here, times little a, which is the 12 here, times the sine of angle C, which is 110. Again, this comes straight from this area formula that we just found by solving for H. Okay, all you do here is plug this straight into a calculator. So grab your calculator. Instead of 1/2, I'm going to put 0.5 times 15 times 12 times the sine of 110. Hit enter, and I get 84.6. And then just look at your units as well. Area is always going to be a square because these really had centimeters attached to the 5 and the 12. So we square our centimeters, or just centimeters squared right there. And that's your area. Not too bad, right? Let's try this one. Just as easy. Again, I'm not even going to label my triangle. I'm just going to look at the two sides. I know two sides right there. and the angle in between them. Now, please note, I know they gave you 3 sides, but you have to use the 2 sides that touch the angle. Okay, so this one's across from it. If you were to label it, it would have the same letter. And notice none of those are the same letter in our formula. Okay, so use the 2 sides with the angle in between them and just plug them in. So it's 1/2 times the side times the other side times the sine of the angle in between them, and straight into the calculator. You've got 0.5 times 23.5 times 24 times the sine of 25, and that gives you 119.2 square inches, or inches squared. And that's your area. Not too bad, right? Okay, look at this last example up here. This will be our last one in this video. Notice the 2 sides that we get right here. We are missing the angle in between them. Okay, so you cannot use 31 and 24 since we don't know this hypotenuse side over here. So you're going to find the angle. That's going to be the easiest. Remember, all 3 angles in your triangle add to 180. So I'm just going to take 180 in my calculator, subtract 24, and then subtract 31. And so this angle is 125 degrees. Okay, now I can go ahead and plug this into my formula. So the area formula is 1/2 times 2 sides, so 17 times 14, times the angle in between those 2 sides, 125 degrees. And straight into your calculator, 0.5 times 17 times 14 times the sine of 125 gives me an area of 97.5. And that's going to be meters squared. And there's example 3. All right, the next 2 examples we'll do in our last video.